Okay, so we have a situation where quarterback throws the football, and the relationship between the height of the ball off the ground, h of x, and the distance the ball has traveled horizontally from the quarterback is given by this expression negative 0.02 times x minus 30 squared plus 20. Okay, so this is a quadratic situation. We're going to talk about what form we're dealing with in a second, but first just think about what's generally going on here. We have a quarterback, and let's say the ball's a little bit off the ground when the quarterback throws it, goes up, reaches a maximum height, and then continues to drop from that maximum height. So the first question asks us, what is the maximum height? So let's first take a look at the form we have here. The form we have is the vertex form, where we have f of x is equal to a times x minus h squared plus k, where hk is the vertex of the quadratic. When a is a negative value, as is the case here, then we have an upside down u like this. When a is positive, we have a right side up u. So what we can see is that this is the vertex form that we're given here, which means that we can immediately identify that the x value of the vertex is going to be at 30, and sorry, that's the wrong thing for there. The x value of the vertex is going to be 30, the y value is going to be 20. And what that means is that the maximum height of 20 yards, so that's our answer here, was reached 30 yards away from where the quarterback released it, and so that's our value here. So once you have this vertex form, you can immediately figure out what the vertex is without doing any calculation. So this, again, x minus 30 means that when x is equal to 30, it'll be at its maximum, and that maximum will occur when y is equal to 20. The next thing we're asked is at what horizontal distance down the field will the ball be when the height is 12 yards? Well, if we say 12 is, let's say, somewhere around here, what we can see is that that's going to happen at 2 points. It's going to happen on the way up to a height of 20 and on the way down. So that just signals you that you're going to need to find two solutions here. When you're working with the vertex form, I believe it is easiest just to keep it in this form and solve without expanding it and using the quadratic formula. So what we'll do here is we will substitute. We're saying that 12 is the height that we're looking for the horizontal distance for, is equal to negative 0.02 times x minus 30 squared plus 20. And so what we want to do is we want to isolate the x minus 30 term, because from there it'll be very easy to solve for x. So first thing we do is we subtract 20 from both sides to get negative 8 is equal to negative 0.02 times x minus 30 squared. Then we divide both sides by negative 0.02. When we do that, we're going to end up getting here 400 is equal to x minus 30 squared. Okay, so what we know now is that the square root of 400 is going to be equal to x minus 30. We're going to square root both sides, and the thing to remember is that when we do that, we're going to get positive or negative square root of 400 is equal to x minus 30. The square root of 400 happens to be 20, so we get positive or negative 20 is equal to x minus 30, which means that x is equal to 30 plus 20, and x is equal to 30 minus 20, so that gives us x value of 50, x value of 10, and that makes sense that here at our x value, let's say of 10, we'd be at a height of 12, and here at our x value of 50, we'd also be at a height of 12. Okay, next problem. We are given that this is a bridge and that this tunnel has a quadratic shape. And so there's several things that we can immediately see. We know that the vertex is going to be at the point 0,8 right here. So we can immediately set it up into vertex form, although we won't know the value for A. We also know the x-intercepts occur at 3, 0 and negative 3, 0, which means that we could also set up the intercept form, the factored form, but again, we don't know A. I'm going to choose to do this with the vertex form because I think it's easier to work with. So what we can set up is that we'll call this f of x is equal to A, we don't know the value of A, times x minus the x value of the vertex, which is 0, squared, plus the y value of the vertex is 8. So we can immediately simplify this to get f of x is equal to A times x squared plus 8. Okay, we've already used the vertex to set this form, but we have two other points that we can now plug in to solve for the value of A. So we can choose either 3, 0 or negative 3, 0. So let's choose the positive value. So we are replacing f of x, or the y value, with 0. And we're saying that that is equal to A times 3 squared plus 8, which means that 0 is equal to 9A plus 8. And that means that we're going to get negative 8 equals 9A. And so A then is going to be equal to negative 8/9. And then we have our full equation, which is that f of x is equal to negative 8 over 9 x squared plus 8. Okay, the next thing is figuring out whether the truck will fit. So we need to think about this. So basically the idea is that the truck, if we say it's got a rectangular shape, and we're told that it's 5 meters high and 4 meters wide, and let's assume that it goes through centered, which is to say that it's going to have 2 meters on that side, 2 meters on this side. And so what we're saying is, is the point 5, 2, or the point 5, negative 2, as we drive through, are those going to be inside the quadratic, on the quadratic itself, or outside the quadratic? If the point is out here somewhere, that means that it's going to hit, it's not going to make it through. If it's inside, it will make it through. So what we're going to do is we're going to figure out when x is equal to 2, what's the y value in our function? If it is less than 5, then we are going to fit. If not, we're not going to fit. So we'll plug it in. So we'll plug in negative 8 over 9 times 2 squared plus 8. And that's going to give us negative 8 over 9 times 4 plus 8. And that's going to give us negative 32 over 9 plus, and I'm going to convert this to ninths, 72 over 9. 8 is equal to 72 ninths, and that's going to give us a value of 40 over 9. And that means that the y value for this is 40 over 9, which means that that's going to be below this 0.25, and so that means that this truck is not going to fit through, because what's happening is that when x should be 40 over 9 or less, we actually have when y should be 40 over 9 or less, we have a y value of 5 right here. So that means it's not going to fit through. Okay. Let's take a look at the next page here. Okay, so we're given this graph, y equals f of x, and we're asked to find the value of f of 4. And basically what that's asking us to do is to evaluate, first we evaluate the innermost function, f of 4. And so when we go here, we can see that f of 4 is going to be equal to 5. And so then we take that and we plug it in. So now we're saying we're actually asking for what f of 5 is, and f of 5 is equal to, as we can see right here, it's equal to 2. So we took the output of our original f of 4, which is the innermost f of 4, and we took that output 5 and plugged it into our outermost, in this case, function f. Okay, we're asked to solve for x given that f of x is equal to 2. So we look for the value where f of x is equal to 2, and we can see that that occurs here when x is equal to 3, and we can also see that occurs when x is equal to 5. So this happens when x is equal to 3 and x is equal to 5. And then we're asked to find the inverse of f of, so the inverse of f of -1. So this is saying that if f of -1, or inverse, is equal to, let's say, p, then what we're saying is that f of p is equal to -1. And so we look for where the function has a value of -1, and we can see that it happens at this point here, and then it's a little hard to tell from the graph, but maybe at this point here. But it certainly occurs when x is equal to -2, when x is equal to -4, and depending on what you think of the graph, when x is equal to +6. Okay, a farmer wishes to grow a 100 square meter rectangular vegetable garden. He has 30 meters of barbed wire, and he's going to need 3 sides because he's going to build it against the wall. So here we have this. This has to be 100 square meters in area, and let's say if this is x, then this is x. And since we've used x plus x, or 2x, what we have left is 30 minus 2x. So what we then have to do is figure out what the area would be, which would be x times 30 minus 2x, and we have to set that equal to 100, which when we expand this, we get 30x minus 2x squared is equal to 100. I want to set this equal to 0, and I want to actually have this term be positive, so I'm going to add 2x squared and subtract 30x from both sides. And so I'm going to end up with 0 is equal to 2x squared minus 30x plus 100. I can divide everything through by 2 because I can divide the left side by 2 and I can divide the right side by 2 to get 0 is equal to x squared minus 15x plus 50. So now to factor this, I'm going to use sums and products. I need two numbers that multiply to 50 and add up to -15. Those two numbers are -10 and -5. And so that means that I can sort of set this to, in factored form, 0 is equal to x minus 5 times x minus 10. And that means we have two solutions to this. We have x is equal to 5 and x is equal to 10. So the dimensions could be either 5 and 30 minus 2 times 5 and 20. Or I could have 10 and then 30 minus 2 times 10, which would be 30 minus 20 or 10. So those would be the two different possibilities. X could be equal to 5, and so this then would be equal to 20. Or x could be equal to 10, and this then would be equal to 10. Okay, on the next one we have 432 meters of fencing, and we need to make these 3 side-by-side identical rectangular enclosures, and we want to figure out the equation in terms of the length x and the length y and the width x represent the total amount of fencing used. So if we call this y, then the amount of fencing that we're going to use is going to be 2y, because we have y over here and y over here, plus 4x, and that has to be equal to 432, because that's the amount we have available for us in fencing. So we can rewrite this to say, by dividing both sides by 2, we get y is equal to, and we'll also subtract the 2x from both sides. Y is equal to 216 minus 2x. The area of this thing is going to be equal to x times y. And so we're going to then replace y with 216 minus 2x to get that the area is going to be equal to x times 216 minus 2x. And we want to get this into standard form, which means we have to expand everything and put it in order from highest degree to lowest degree term. So we get a is equal to 216x minus 2x squared, or a is equal to negative 2x squared plus 216x. Okay, so we have f of x equals 6x minus 3, and we have that g of x equals x cubed plus 2. So we want to find out which of the following is equivalent to f of g of x, which means that we plug g into f. So that means that we are replacing the x here with x cubed plus 2. So we end up with 6 times x cubed plus 2 minus 3, which when we expand gives us 6x cubed plus 12 minus 3, or 6x cubed minus or plus 9. So the answer here would be D. And then we're to evaluate f of g of 3. Well, we now know that f of g of x is equal to 6x cubed plus 9. So we can just plug in 3 to that. And so we can do 6 times 3 cubed plus 9. And that's going to give us 6 times 27 plus 9, which is going to give us 162 plus 9, which is going to give us 171. So the answer here is A. Okay, factor each of these completely. Okay, first step in factoring is looking for common factors. When we look at these 4 terms here, we can see that they all have even coefficients, so we know we can divide by 2, and that's the largest common factor of these coefficients. We also know that each of them has at least an x to the first, so we can factor that out. Not all of them have a y, so we cannot factor that out. So what's left after we do this is we're going to end up with x squared y. We're going to end up with negative 3x cubed y squared. We're going to end up with 5. The x is factored out, so we're just left with y to the 5th. And then we're going to be left here with negative 11. The x has been factored out. There is nothing more that we can do to factor what's inside here. So this is the full factorization. Okay, next one, looking at seeing whether we can do this by products and sums. So we're looking for, can we find 2 numbers that multiply to negative 21 and add up to positive 4? Yes, we can. We can find those two numbers are positive 7 and negative 3. And so this can be factored into x plus 7 times x minus 3. Just as a check, 7 minus 3, negative 21, 7x, negative 3x, positive 4x. Okay, the next one is a difference of perfect squares because both terms are perfect squares. So this can be factored into the form x minus 9 times x plus 9. You could also think of this as x squared minus 0x minus 81, and we could use products and sums where we're looking for 2 numbers that multiply to negative 81 but add to 0, which means the 2 numbers would have to be opposites, which means 9 and negative 9. Okay, next one. First thing is note that we have, instead of x squared and x, we have x to the 4th and 5x squared. We can use products and sums here, and that gives us 2 numbers that have to multiply to negative 36 and add up to positive 5. And those 2 numbers are going to be negative 9 and positive 4. So we're going to end up with x squared minus 9 times x squared plus 4. And again, we have a difference of perfect squares, so we can keep factoring. So we have x minus 3 times x plus 3 times x squared plus 4. And now that's fully factored. There's nothing we can do with the x squared plus 4. Okay, next one. So people have learned different methods for solving it when we have an a value here that is other than 1. So here's the way we're going to do it. We're going to we're going to first do the products and sums, except what we need to have it multiplied to is not this value, but this value times 3, or negative 21. And then we also have to have it add up to negative 20, which means that the values that are going to go here are going to be negative 21 and positive 1. Okay, so now we're going to set up a multiplication table, and we know that this is going to be 3x squared, and this is going to be negative 7. We also know we're going to have a negative 21x and a positive x, and those can go in either place. So let's just put this negative 21x here and positive x here. Okay, so now what we do is we take the greatest common factor of this first row, which is going to be 3x. That goes here. We take the greatest common factor of x and negative 7, which is just going to be positive 1. That goes here. We take the greatest common factor of 3x squared and x, which is just going to be x here. And we take the greatest common factor of negative 21 and negative 7. We always take the sign of the value closest to the column heading or row heading. So in this case, it would be a negative 7, and that's our factorization. We end up with 3x plus 1 times x minus 7. So again, the 1 times the negative 7 gives us negative 7, and the 1x and the negative 21x gives us negative 20x. Okay, 4 terms here. And what we're looking for, and you can kind of tell from the arrangement, that we're going to be factoring by grouping. So we take these first two, and we can take a common factor of x squared out of both of them, and that leaves us with x plus 2. And then we have minus 9. We're taking the common factor of negative 9 out, and that leaves us also with an x plus 2. And this is what we're looking for. We're looking for both of these to be the same, because what we can do then is we can say, well, we have these two terms, and we're going to factor x plus 2 out of both of these two terms, which is going to leave us the x squared and the negative 9. And this, again, can be factored into x plus 2. And again, we have a difference of perfect squares. So x minus 3 times x plus 3. Okay, moving right along. Okay, this we'll look at in a separate video. Okay, moving on to probability here. We are given a two-way table, and we're told that we have data about 2 characteristics of passengers: what class of travel, first, second, or third, and whether they survived or died. So we're using this two-way table, and we have 2 different categorical variables, survival and class. We are told that we're given the values here for how many are in each combination of survived or died and class of travel. So we can now fill in these columns here, which are the totals. So 197 plus 122 is going to give us 319. This next one is going to give us 261. The next one is going to give us 627. And then we also find the column totals. So we'll have 442 people who survived versus 765 who died. When we add these two together, we get 1207. And as a check, when we add these 3 together, we also get 1207. Okay, probability that a person picked at random from this entire group survived. Well, we know that the denominator is going to be 1207 because we're picking from the entire group. And the number of people who survived, 442. Okay, so the probability that a randomly selected person from this 1207 people will survive is 442 out of 1207. Probability someone is first class, again, out of 1207, but this time we're looking at this 319 total here, so that would give us 319 as over 1207 as the probability. Probability that someone died given that they're first class. Okay, so what this vertical bar means is that we're no longer looking at the group. We're only looking at the group that satisfies this condition to the right of the vertical bar, which is to say that they're first class. So we're only looking at these 319 people, which means that will be our denominator. Of those, 122 died. So if I pick a person at random from the first class passengers, the probability that person survived or died is 122 out of 319. Okay. Then we look at the probability that someone who died was first class. So now we're thinking about, okay, we're only looking at of all the people who died, that's now our denominator. How many of them were first class passengers? That is the same numerator that we had above, because in both cases we're talking about first class passengers who died. But the denominators are different, and the denominators are indicated to us by what is following the vertical line here. So for the next one, we're saying of those who survived, so that's out of 442 people, how many of them were third class? Well, that would be 151. And so what that means is that the probability that a randomly selected person who survived, the probability that that person was in third class is 151 out of 442. If I now say out of all the people who were second class, which would be 261 people, of those, the number that survived, 94. And what that means is that the probability a randomly selected person from second class is survived is 94 out of 261. Okay, continuing with probability. So we have here, again, two different variables. We have whether the Yankees won or lost, categorical variable, whether or not they scored 5 or more runs. And we have the number that, in this case, instead of the absolute number, we have the proportion. And so we're told the probability the Yankees will win a game is 0.59, which is this value right here. And we're also told the probability that the Yankees will score 5 or more runs is 0.61. And the probability the Yankees lose and score fewer than 5 runs is 0.32, this number here. Okay, so we can start to fill in some of these values here. 0.61 plus this value here have to add up to 1, so this will be 0.39. By the same reasoning, this has to be 0.41. Well, now we know this column, the lose column, has a total 0.41, so this has to be 0.09. And that means this has to be 0.52 to make this row add up to 0.61. And finally, we have to have a 0.07 here. Okay, so now we're asked, what is the probabilities that the Yankees win and score 5 or more runs? So that would only be those people in the win column and the 5 or more runs row, which would be the 0.52. So the probability here would be 0.52. What's the probability the Yankees will lose given that they score fewer than 5 runs? So now we're looking only at this 0.39 as our denominator, and as our numerator, we're going to have the number of times that they lose, which would be 0.32. So this would be 0.32 out of 0.39. And when we come up with an approximate value for that, that gives us around 0.82. So what we're saying, the probability that the Yankees will lose given that they score fewer than 5 runs is 0.82, or about 82%. What's the probability that the Yankees will win given that they score fewer than 5 runs? Okay, so now we're looking again at the situation where they score fewer than 5 runs. And so again, that's 0.39. But we're looking now at the probability that the Yankees will win given that they score fewer than 5. So now it's 0.07 divided by 0.39, and that's going to be approximately equal to 0.18. Okay, moving on here. Okay, so we have a tree diagram and a two-way table. And we want to take the values from the tree diagram and import them into the table. Okay, so first of all, we want to know, we know we have 1,000 students. And so we want to figure out, okay, how many of them are sophomores, how many of them are juniors? We'll start there. So there's a 0.60 probability that a student is a sophomore, which means that would be 600 out of the 1,000, and that means that 400 would be juniors. Okay, we know that of the sophomores, 0.32 say that they would like most to have the superpower to fly. So 0.32 of 600 is going to give us a value of 192. 0.32 times 600. For invisibility, we have 0.44, which means that we're going to end up with 0.44 times 600, or 264, and finally 144. And just as a check, we have to confirm that these all add up to 600. These two add up to 408, plus 192 gives us 600, so that is correct. Okay, for juniors, then 0.5 would prefer to have a superpower of flying, so that's 200 out of the 400. 0.35 would prefer to be invisible, which would be 140. Again, that's 0.35 times 400. And other would be the remaining 60. Now we can also create the row totals, which would give us here 392. Here we would get 404. And here we would get 204. And just confirming, 204 plus 404 gives us 608, plus 392 gives us 1,000, so that works. Okay, so now we want decimals rounded to the nearest hundredths. So the probability that a randomly selected student is a sophomore is 600 out of 1,000, so this is equal to 0.6. Probability that a randomly selected student wants to fly is 392, our row total for flying, out of 1,000, and so we are rounding to the nearest hundredth, so it would be 0.392, which rounds to 0.39. The probability that a randomly selected student is a sophomore or wants to fly means that we want everybody in this row, in this column here, so the 600, plus the 200 juniors who also want to fly, or who do want to fly. So we add that 200 to the 600, and that would give us 800 out of 1,000, or 0.8. The other thing you could do is you could add the column total of 600, the row total of 392, which would give us 992, but then you have to subtract the 192 here, because otherwise we'd be double counting them. That would give us 992 minus 192, which again would give us 800, so probability of 800 out of 1,000, or 0.8. Okay, the probability that a randomly selected student is a sophomore and wants to fly, that would just be our 192 sophomores who want to fly, so that would be a 0.19 here, 192 out of 1,000. Okay, we're then asked the probability that a randomly selected student wants to fly, or I'm sorry, given that a randomly selected student wants to fly, what's the probability that the student's a sophomore? So we're saying out of the 392 students who want to fly, what's the probability that a randomly selected one is a sophomore? Well, that would be 192 out of 392, which gives us a probability of 0.49. 192 divided by 392. Given that a randomly selected student wants to fly, find the probability that the student is not a sophomore. That would basically be just everybody who's not in the 0.49, so it would be the 200 over 392, which is just going to be 1 minus 0.49, or 0.51. Given that a randomly selected student is a sophomore, so now we know this is going to be out of 600, that's the number of sophomores. Find the probability that the student wants to fly, so now we're doing 192 again, but this time it's out of 600, and so that's going to give us value of 0.32. And given that a randomly selected student is a sophomore, find the probability the student wants to fly or be invisible. So when we look at all the sophomores, again, that's out of 600. And when we add those first two row values in that column, flying and invisibility, we end up with 456. And when we find the decimal equivalent, that would be 0.76. Okay, so now we have a scenario where we want to draw a tree diagram. And so the first thing we're told is that we have three different machines. And so our first row is going to have three different branches. We're going to have A, we're going to have B, and we're going to have C. And we know that A produces 0.6 of the parts, or 60%. B and C produce 0.3 and 0.1. We also know that we're going to have either defective or not defective, and we're going to have that for each of these: defective, not defective, and defective, not defective. So then we have our conditional probabilities, which are that out of all the machines produced by A, about 10% are defective, which means that 90% are not defective. For machine B, on the other hand, we have 0.3 defective and we have 0.7 not defective, and for D, it's 0.4 and 0.6. So now we multiply down the tree to get our probabilities that, for example, a machine is produced by A, that a identical part is produced by A and is defective. We multiply down the tree. Here we would get 0.54. Here we would get 0.09. Here we would get 0.21. Here we would get 0.04. And here we would get 0.06. So we have 6 different categories: part produced by A, by B, or by C, and within each of those, either defective or not defective. So for example, 54% of the parts were produced by machine A and are not defective. Okay, if we choose a part produced by one of these 3 machines, what's the probability that's defective? Well, the defectives are the 0.06, the 0.09, and the 0.04. When we add those together, we end up with 0.19. So there's a 0.19 probability, or 19%, that a randomly selected part will be defective. If a part is defective, which means that out of those 0.19, what's the probability that it was produced by machine A? Well, that would be this, 0.06 over 0.19, and that's going to be approximately equal to 0.32. So in other words, if you randomly select a part that's defective, the probability that it was produced by machine A is approximately 0.32. Okay, next we have these spinners here, where when we spin, the probability that we land on a given number is proportional to the area. So we're going to create a tree diagram, and we're going to say that you first will, the way it works is you're going to spin the one on the left first. So you have 3 possibilities here. You have possibility of getting a 5, possibility of getting an 8, and a possibility of getting a 6. The probabilities based on these diagrams: this is a 0.5, it's half the area. This is a 0.25, and this is a 0.25. And then off of each of these, we have 3 possibilities. And those are the possibilities of getting a 3, a 5, or a 4, a 3, a 5, or a 4, a 3, a 5, or a 4. And those probabilities are, again, 0.5, 0.25, 0.25, 0.5, 0.25, 0.25, 0.5, 0.25, 0.25. And again, we're going to multiply down, so we're going to have 9 different combinations here. So when we multiply down here, we get 0.25, we get 0.125, we get 0.125, we get 0.125, 0.0625, 0.0625. Here we get again 0.125, 0.0625, and 0.0625. Okay, so the actual values here that we're getting in each of these, so here would be 3 and 5, so this would be 8. This would be 5 plus 5, or 10. This would be 5 plus 4, or 9. 6 plus 3 would be 9. 6 plus 5 would be 11. 6 plus 4 would be 10. I'm sorry, these are 8. 8 plus 3, let me redo these. So we would have here 8 plus 3 is 11, 8 plus 5 is 13, 8 plus 4 is 12. Here we now have 6 plus 3 is 9, 6 plus 5 is 11, 6 plus 4, 11, and 6 plus 4 is 10. Okay, so the probability of getting exactly 11 points is this plus this. So that would be 0.125 plus 0.0625, which would be 0.1875. Okay, now we are asked, what's the probability that, given that we spin a 5 on exactly one spinner, what's the probability of getting 11 points? Okay, so the probability of spinning a 5 on exactly one spinner. So we have, of all those possibilities, that would be a 5 and a 3, a 5 and a 4, a 8 and a 5, and a 6 and a 5. So we have to add all those together. So we have 0.25 plus 0.125 plus 0.0625 plus another 0.0625. So that means when we add all these together, we're going to end up with 0.5. That's the probability that we get a 5 on exactly one spinner. Out of all of these, the one place that we get an 11 is here with this 6 and a 5. The only other 11 we can get is an 8 and a 3, and so that isn't included in our set of combinations that we're looking at. So our denominator is going to be 0.5, and our numerator is going to be 0.0625. And when we evaluate that, that again is equal to 0.125, or 1 out of 8. So that's the probability that if you roll a 5 on exactly one spinner, not on both, there's a 1 out of 8, or 0.125 probability that you will get an 11. All right, a little geometry here. Okay. So first of all, we're given that DE and AB are parallel. Okay. So what that means is that we can apply a number of ideas here. One is that triangle CDE and CAB are similar to each other because we know that these angles are congruent, these angles are congruent, and C is congruent to itself. Not that we need that, but by AA similarity, the triangles are similar. We also know that that CD over CE is going to be equal to AD over EB, or you could also say that CD over AD is equal to CE over EB. Okay, So we also know that CE is equal to 2, EB is equal to 3, AD is equal to 4. This is X that we're looking for. So we can say that X over 4 is equal to 2 over 3, which means that with cross multiplying, 3x is equal to 8, so x is equal to 8/3. In this case, where we have CD is equal to 6, AD is equal to 4, DE is equal to 3, and we are asked to find AB. Here we can use the fact that these triangles are similar, but we have to be careful because triangle CAB, the side CA actually has a length of 6 plus 4, or 10. So we can say that 6 over 6 plus 4, so this side over this whole side, is equal to DE, or 3 over AB, which is our x. So again, cross multiplying, we can get that 6x is equal to 3 times 6 plus 4, or 30, which gives us that x is equal to 5. Okay. I'm going to skip 17, but what I'm going to do is go on to 18. Okay, we have PQ is equal to 5, and we have that QR is equal to 12. We have a right triangle, and so one of the first things we can do is see that that PR squared is equal to 5 squared plus 12 squared, which is equal to 169. So PR is equal to 13. So this whole side here is equal to 13. Okay, so we actually have 3 similar triangles in here because these angles add up to 90 degrees. Well, this angle and this angle here add up to 90, so that means that this angle here, SQR, has to have the same measure as QPS. And it also means that this angle down here has to have the same measure as PQS. So we have all 3 of these triangles that are similar. So what we can say is that, and we're trying to find the length of QS here, we can say that, and we'll call this X, that X over 5 is going to be equal to 12 over 13. Okay, so we know that the side length 5 is the hypotenuse of triangle QPS, and we know that 13 is the hypotenuse of triangle PRQ, the big triangle. We also know that the side X is the side opposite this angle here, and we also know that the side 12 in the big triangle is the side opposite this angle here as well. And so that means that this proportion has to hold, and when we work this through, we get 13x is equal to 60, and so x is equal to 60 over 13. Okay. All right, for this one, we have this figure here, which is a hexagonal prism, which means that its bases are 2, in this case, regular hexagons, and it has an altitude or height, the distance between the 2 bases, of 9 centimeters. So this distance here is 9. Okay, so we want to find the volume. The volume for this thing is going to be equal to the base area times the height or the altitude. So in this case, times 9. So we have to figure out the base area. So we have this regular hexagon here, which we can divide into 6 equilateral triangles. Each triangle then has side lengths of 6, which means that we can split this into 2 30, 60, 90 triangles, because this is a 60-degree angle here. This would be half of that. So this would be 30-degree angle up here, and this is the right angle. So what we know is that in a 30, 60, 90 triangle, the hypotenuse is double the length of the side opposite the 30-degree angle. So that means this would be 3. We also know that the altitude of this triangle would have to be the shortest side 3 times root 3. So that means that the area of this whole triangle, since this side is 6, the whole side, is going to be 6 times, and again we said that this is 3 root 3. It's going to be 6 times 3 root 3 over 2, which is equal to 9 root 3. That's the area of one of the triangles in this prism base, and so the area of the base area has to be equal to 6 times 9 root 3, which is equal to 54 root 3. And so now when we multiply the base area times 9 to get our volume, we're going to have 54 root 3 times 9, which is going to give us a total of, so 9 times 54 is 450 plus 36 is 486 root 3. Okay, so that's the volume, and that's in units of centimeters cubed. Okay, the surface area is going to be equal to the lateral surface area, which would be the area of all 6 of these side rectangles, each of which is 6 by 9. So we have 6 by 9, and then we have 6 of them, and so that's going to give us 324 centimeters squared. And then the two bases, each 54 root 3, is going to give us 108 root 3. So we're going to get 54 root 3 plus 54 root 3, 108 root 3, plus 324, and that is, again, in units of centimeters squared. Okay, so that's our surface area. Okay, the cone. 4-inch tall cone has a volume of 12 pi inches cubed. What is the total surface area? Okay, so first of all, the volume of a cone is equal to 1/3 pi r squared, where r is the radius of the base, h, where h is the height. So we know that in this case, 12 pi is equal to 1/3 pi times r squared times 4. All right, so we need to solve for r. So the first thing we can do is we can divide both sides by pi. We can divide both sides by 4. And so we end up with 3 is equal to 1/3 r squared. Multiplying both sides by 3, we get 9 is equal to r squared. So r is equal to 3. So that means that we have a radius of 3. This is 4. And so we have this right triangle here that turns out to be a 3, 4, 5 right triangle, which means that this thing here, which is the slant height, is equal to 5. Okay, the total surface area then is equal to pi r squared plus pi r slant height. And so that's going to give us pi times 3 squared plus pi times 3 times 5. It's going to give us 9 pi plus 15 pi is equal to 24 pi. And our unit here is inches squared. All right, next. We have a triangle that's all made up of special right triangles. So we have a 45, 45, 90, which means that B and C have the same measure, and A is going to be C times root 2. We also know that in this triangle that C is going to be half the length of D, and that c times root 3 will give us the length of e. Okay, so if a is equal to 12, in order to get from the hypotenuse to the side length, we have to divide by root 2. So that would give us that b is equal to c is equal to 12 over root 2, and we'll multiply top and bottom by root 2 to get 12 root 2 over 2 is equal to 6 root 2. So those are the lengths of b and c. So since we know that d has to be double the length of c, we know that d has to be equal to 12 root 2. And we know that e is going to be equal to c times root 3, so that's going to be equal to 6 root 2 times root 3 is equal to 6 root 6. Those are exact values. If b is equal to 12, well, that means that c is equal to 12, a is just equal to 12 root 2, d then would be equal to double 12 or 24, and e would be equal to c times root 3 or 12 root 3. If c is 12, then we get the same answers as we got in 22 because b and c have to have the same measure. And so this would give us that b is equal to 12, a is equal to 12 root 2, d is equal to 24, and e is equal to 12 root 3. If, on the other hand, d is equal to 12, then we get that if d is equal to 12, then c has to be half of that. So c would be equal to 6. E would be equal to c times root 3, which would give us 6 root 3. Since c is 12, since c is 6, b would also have to be 6, and a would have to be just 6 root 2. If e is 12, so since e is root 3 times c, that means that c would have to be equal to 12 over root 3, which when we multiply by root 3 over root 3 is going to give us 12 root 3 over 3 or 4 root 3. D is equal to double c, so it's equal to 8 root 3. B is equal to c, so b would be equal to 4 root 3. And a is equal to root 2 times b or times c, so a would be equal to 4 root 3 times root 2, which would be equal to 4 root 6. All right, so here we're told that this is a 45-degree angle, that this whole thing is 105, and since this is a right angle, we know that this angle here has to be 45 degrees angle. Let's call this, we have ACL, let's call this D. That angle, that the measure of angle DLC has to also equal 45 degrees, which means that this angle here has to equal 60 degrees, which means that this angle here has to equal 30 degrees. Okay, so, and we're told that CL, this thing here, is 12 root 2. Well, that means that DC is equal to 12 root 2 divided by root 2, or 12. And that's DC, and DL is also equal to 12. Well, that means that the altitude to CA, which would be LD, is 12, so this would be 12. The area of triangle CAL, this is the whole triangle, so we know that this is 12. We need to figure out the length of this thing here. And again, we also know that this is 12. So since we know that this LD is 12, we know that this is double that, and we know that this is that times root 3, because again, of the properties of a 30, 60, 90 triangle. So the area is going to be 12, which is the altitude here, times 12 plus 12 root 3, which is equal to 144 plus 144 root 3. And then we're also asked to find the length of side LA, which we already did, which is double this altitude here, or just 24. All right, the perimeter of an equilateral triangle is 18. What is its area? Okay, so we have this equilateral triangle. Since its perimeter is 18, we get this is actually the same triangle that we found before, where we said that this thing, these are each 3, and so this is going to be 3 root 3, and so the area is going to be the base of 6 times the altitude of 3 root 3 divided by 2 is going to give us 18 root 3 over 2, or 9 root 3, and that would be centimeters squared. All right, given what do we know about these? Okay, so sine of theta is just going to be equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And these each are the reciprocals of what's above them. So this is hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite. All right, a right triangle has legs of 5 and 6. So let's say this is 5, this is 6. So this would be the square root of 5 squared plus 6 squared equals root 61. Okay, so the sine of theta, where theta is the angle opposite the 5 unit long side, so this would be theta. So the sine of theta would be opposite over hypotenuse, would be 5 over root 61, which means this would be root 61 over 5. This would be 6 over root 61, so this would be root 61 over 6. And the tangent of theta would be 5 over 6, which means the cotangent would be 6 over 5. All right. Exact. Okay. So we have 30, 60, 90. So let's just assign values here. So this is 1, this is 2, this is root 3. And this is the 60-degree angle. This is the right angle. And in the 45, 45, we have 1, 1, root 2. Okay, so the sine of 30 degrees is opposite, or 1 over hypotenuse. And so if that's 1/2, this would be 2. I'm sorry. So the cosine of 45 degrees would be opposite or adjacent over hypotenuse would be 1 over root 2, or root 2 over 2. The tan of 60 degrees would be opposite or root 3 over adjacent, so this would be root 3. And we're also asked for the cosecant of 60 degrees, which would be 1 over the sine of 60 degrees. The sine of 60 degrees would be root 3 over 2, so this would be 2 over root 3, which is equal to 2 root 3 over 3. The secant of 30 degrees would be 1 over the cosine of 30 degrees. The cosine of 30 degrees would be adjacent, or root 3 over 2, so this would be 2 over root 3, equal to 2 root 3 over 3. And the cotangent of 30 degrees would be 1 over the tangent of 30 degrees. The tangent of 30 degrees is 1 over root 3, so this would be root 3 over 1. So there we have it. Okay, solve the following. Okay, so we're given the sine, so let's call this, let's say, we'll call this angle x. We're told the sine is 2 over 3, so let's just say that the side opposite is 2 and this is 3, which means this would be the square root of 3 squared minus 2 squared, which would be equal to the square root of 5. And in this case, let's say if this is angle x, then we have the cosine of x is root 2 over 5. So we would say that this is 5, this is root 2. And that means that this side, the remaining side, would be the square root of 5 squared minus root 2 squared, which would be square root of 21. So this would be the square root of 21. Okay, so the tangent of x here would be opposite over adjacent, or 2 over root 5, which would be equal to 2 root 5 over 5. And here we're asked to find the sine of x, which would be the opposite over hypotenuse, which would be root 21 over 5.